Hey everybody, I feel like it's been forever since I've seen you. I hope you're all doing well. Not too fond of the idea of having to put myself out here on YouTube, but at least my face is concealed. Can't stand the sound of my own voice, but hopefully you're going to be okay with it. So the new format moving forward is going to be hopefully pretty similar to what we had before, where I'm going to provide you with a note sheet. And then a filled in copy of the note sheet as if you were absent. And then to supplement both of those items, you're going to get a video of me filling out the note sheet. Really, the only difference between what we're doing here and what we did in class is that you're going to be able to watch this video on your own. You can pause me, you can turn the volume down on me, right? So these kinds of things. The bummer is you won't be able to ask me questions while we're moving along, but by all means, after you watch the video, email me with your questions and I'd be more than happy to help you out. All right, so the materials in Canvas are going to be organized into modules. I mentioned this in announcements, but just to clarify, so the modules will open up and every day I'll be posting the 3 items I just mentioned. So you'll get a blank copy of the note sheet. You can print it out and then work along with me through the video if that's what you want to do. I'll also upload a completed copy of the note sheet. So if you just want to watch the video and then print out a copy of the notes, you can. Now you don't have to print out any notes. If you want to just write your own notes on a sheet of paper, that's going to be fine too. Just remember that you get to use your notes when you're taking your quizzes. So the more organized they are, I think the easier it will be for you. Okay, so we're going to get started with chapter 9, and then also so you're aware, the items that you just tested on the midterm, they're not going to be tested again. They won't be quizzed. They won't be on the final. So when we get to the final exam in about a month, it will only cover the units that we cover from this point forward. So I'm not telling you to have a bonfire with all your old notes, but if you want to set them aside and kind of, put that stuff out of memory and make room for the new stuff, that's totally going to be fine. Okay, and this Actually, we're going to be combining units 9 and 10 for the next quiz because 9 is just really short, and actually they kind of connect. What we're looking at today specifically is the metric system of measurement. Now, before we start with the metric system, the standard system of measurement is what we use in the United States. So in the United States, we use what is called the standard or English system of measurement. And we have inches, feet, yards, miles. Those are all increments that we use to measure length or distance. So here in the US, we measure, really small distances or lengths with inches, a little larger with feet, a little larger with yards, and really long distances with miles. If we're measuring in ounces, pounds, and tons, then we are measuring weight. Okay, again, a really small weight we would measure in ounces, a little larger in pounds, and then really heavy we'd measure in tons. And then for liquids, we commonly measure the volume of those liquids in ounces, cups, liters, quarts, and gallons. If we're looking for volume of a solid, then we're going to be using cubic lengths like inches cubed, feet cubed, yards cubed, miles cubed. These are all, again, for measuring volume. And then temperature in our standard or English system, we know, is measured in degrees Fahrenheit. And we're going to talk more about temperature in 2 lessons from now, okay? So that's our standard unit of measure. That's how we measure things here in the United States, but pretty much every other country outside of the United States uses the metric system. So we use the standard English, or even sometimes it's called the customary system, but pretty much everywhere else they use the metric system, where your base unit of measurement for length is the meter. And the base unit of measurement for mass. Mass is really similar to weight. It's not exactly the same thing, but you can think of them as the same thing. And in the metric system, grams. Let's say meters there. Grams are the base unit for length. For mass, meters are the base unit for length. And then if we're measuring volume for liquids, we're going to be looking at liters as the base unit. Now I say the base unit, there are probably some other words that you can connect like to the word meter. Maybe I'm sure you've heard of, centimeter or kilometer or kilometer. And those prefixes that go in front of those base units we're going to talk about in just a few minutes. But those are your basic units of measure for the metric system. Temperature in the metric system is measured in degrees Celsius. And then the nice thing, excuse me, I'm sorry. The nice thing about our metric system is making conversions. If you want in the standard system to, unlike the standard system where you have different measurements, like if it's a small amount or small length, we use inches. If it's a larger length, we might use feet, and a really larger length, we'd use miles. In the metric system, it's still going to be some form of meters. So you'd use a meter in a comparable situation to using, let's say, a yard, but then you have a centimeter that's smaller, or you have a kilometer that's larger, but it's still surrounding that base unit. It's just a prefix added to that base unit. So unlike the standard system with different units to measure small, medium, large amounts, the metric system simply adds a prefix to the base unit. Okay, so all measurements of length in the metric system will involve the word meter, and all mass measurements will involve the word gram, and then all volume measurements for liquids would involve the word liter, just with a prefix added. Okay, so let's talk about those prefixes. We have the prefix kilo. So we could put that prefix in front of any of our base units. So we can have a kilometer, a kilogram, a kiloliter, and the abbreviation for it's just going to be a K. I should have put the abbreviations for these two. The abbreviation for meter is just M. The abbreviation for gram is G, and the abbreviation for liter is L, and I prefer to use a capital just that it doesn't look like a 1, although a lowercase is acceptable. Okay, now kilo is a prefix that could go in front of any of those. So again, kilometer or kilometer, kilogram, and then kiloliter. Those are all metric units of measure. And then we have, after the kilo, we have the hecto prefix. Hecto is abbreviated with an H. So again, we could have a hectometer, a hectogram, a hectoliter, and the base kilo means, if you put that prefix in front of the liter, it means multiply by 1,000. And we're going to talk about that more in a few minutes, but a kiloliter would be 1,000 liters. And then you put the H in front of the liter or meter or gram, it would be 100 of those, so it's multiply the base by 100. And then you have the deca prefix, which is going to be abbreviated DA. You have the base unit, no prefix, just your base unit is going to be your meter, gram, or liter. So no prefix, you're just going to have an M or a G or an L. And then so we get larger, multiply by 10 is deca, multiply by 100 is hecto, multiply by 1,000 is kilo, and then we get smaller as we move the other direction. So if we're going to divide our base unit by 10, so if we had 1 liter and we put deci, the prefix deci in front of that deciliter, that would be 1/10 of a liter. And the abbreviation for deci is just a D. And these two, deca and deci, seem to be confused quite a bit. Make sure when you're abbreviating deca it's DA, and then deci is just the D, because they're definitely two different things. Multiplying by 10 versus dividing by 10 would give you a much different result. Okay, if we had a 1/100th of, let's say, a meter, then we would have a centi in front of it, centimeter. Centimeters going to be, or centi, it could again go in front of liter or centigram too, is going to be a C, so that would be 1/100th of your base. And then the last one is milli. So a milliliter, a milligram, millimeter is going to be abbreviated with an M, and that's 1/1000th of the base. So 1 meter, for instance, would be 1/1000th of a milliliter. All right, so we're getting smaller as we move down there and larger as we move up. Okay, so any of these prefixes could be put in front of our base units, our meter, our gram, our liter. And we're going to see how that looks on the back here. So let's start with our meters. If we had a kilometer or kilometer, either pronunciation is acceptable, a kilometer or a kilometer. If we had 1 kilometer or 1 kilometer, that means we have 1,000 of our base unit, 1,000 of our meters. Okay, 1 hectometer, which we would say HM, would be 100 meters. If we had a decameter, we had 1 decameter, deca is dA and meters m, then we would have 10 meters, right? If we had just 1 meter, that is our base, that is our 1 meter. Decimeter, so 1 decimeter is just going to be dm. That would be 1/10 of a meter, 1/10 of a meter. If we had 1 centimeter, that would be 1/100th of a meter. So we're getting smaller. And then lastly, if we had 1 millimeter, then we would have 1/1000th of a meter. And then decimal form of this, right, 1/10 of a meter would be 0.0, 1/10. This would just be 0.1 of a meter, or here would be 0.01 of a meter, or here would be 0.001 of a meter. Okay, I don't know if you prefer fractions or decimals, doesn't really matter, but basically here, multiplying by a power of 10 as you go this way, right, multiplying by a power of 10, so multiply by 10 to the first to get 10, by 10 squared to get 100, or 10 cubed to get 1,000. So this, to go from the base in this direction, we are multiplying by a power of 10. Why can't I write power of 10? And then if we go from our base this direction, we are dividing by a power of 10. Okay, get this out of the way real quick. And that's going to be true for all of them, okay? So we put the same prefixes in front of the base unit of a gram. So if we had 1 kilogram, then we would have 1,000 grams. If we had 1 hectogram, then we'd have 100 grams. If we had 1 decagram, that'd be 10 of the grams. If you had, obviously, 1 gram, it's going to be 1 gram. If you had a decigram, oops, look at, I made the mistake I told you to be careful with. This is DAG here. 1 decigram, just DG, is 1/10 or 0.1 of a gram. And then 1 centigram would be 1/100th of a gram. I just don't like how that looks there. And then 1 milligram would be 1/1000th of a gram. Okay? And then lastly, works the same way here. We put our prefixes in front of our base unit of a liter. Then we have a kiloliter. Now you can use a lowercase l, I just prefer the capital because it looks like a 1 and I don't like it. If you're going to use a lowercase l, I would say maybe make it a cursive so that it doesn't look like a 1. Otherwise, let's use the capital, okay? So a kiloliter, 1 kiloliter. 1 kiloliter is going to equal 1,000 liters. 1 hectoliter is going to equal 100 liters. 1 decaliter is 10 liters. Obviously, 1 liter is 1 liter. 1 deciliter is 1/10 of a liter. 1 centiliter is 1/100th of a liter. And then 1 milliliter is 1/1000th of a liter. So really small amounts as you're moving there to the right, and then much larger amounts as you're moving there to the left, okay? So the nice thing about converting in our metric system, and this is why most of the world uses this system, is converting to, let's say, liters to kiloliters, right? Going from a small amount to a larger amount, or going from liters to centiliters, or moving around here from one unit of measure to another within that base is just multiplying by a power of 10 or dividing by a power of 10. And what that does is it moves the decimal. Let me show you on my scratch paper here, right? If you took 2 and you multiply it by 10, you end up with 20, right?
Now what's happening when you multiply by 10 to go from 2 to 20 is basically you're just moving the decimal, right? You add a 0. So instead of being 2 where the decimal is here, it moves here. If you were to take 2 and you were to multiply it by 1,000, right, it becomes, well, let's not jump, let's go 100 first. Multiply by 100, then you have 200. The decimal goes from here, right, to here. It's moving twice. So when you multiply by 10, you move the decimal once. Multiplying by 100 moves it twice, and that's once to the right, and that's twice to the right. If you multiply by 1,000, right, you would move the decimal 3 times to the right. And what happens when you divide by 10? So if you took 2 and you divided it by 10, right, 2 divided by 10 is 2/10. Okay, that's 0.2. So the decimal goes from here to here. It moves the other direction. And if you divided by 100, it would move 2 times to the left. If you divided by 1,000, it would move 3 times to the left. So when you're converting within this metric system, if you're multiplying by a power of 10 or dividing by a power of 10, really all you're doing is moving the decimal to the left or to the right. Okay? So multiplying or dividing the base by a power of 10 simply moves the decimal. It moves the decimal. So these conversions are really simple. Unlike in our standard system, which we'll look at tomorrow, but if you want to convert from, let's say, inches to yards, well, you're going to have to know how many inches are in a foot and how many feet there are in a yard, and you have to do multiplying and dividing by numbers that aren't powers of 10, and that makes the conversion a little trickier. Whereas multiplying or dividing by a power of 10, which is exactly what happens here with these prefixes, simply moves the decimal. It's really easy. So to determine how we're moving the decimal, we don't actually have to remember whether we're multiplying or dividing, and whether it's multiplying by 10 or 100 or 1,000 or dividing by 10 or 100 or 1,000. It's going to be simple as long as we can remember the order of these prefixes. So the prefixes, kilo, hecto, deca, the base, then deci, centi, and milli. If you look at those beginning letters, there's a little phrase that's been developed to help people remember the order of those letters, and maybe you've heard this before. It's King Henry died by drinking chocolate milk. That's to help you remember the order of the prefixes and that base unit. And we're going to, if we can remember that, use that order to determine how to convert, let's say, at 8 decameters to meters. Okay? What we're going to do is we're going to move the decimal according to where it starts and needs to end in that order of the base unit. Okay? So I'm going to try to show you what I'm talking about. Let me go back to my scratch paper for a second, and then this will be really simple. So if in the last box there we had kiloliters, hectoliters, decaliters, we had our base, and then we had deciliters, milliliters, and centimeters, liters. Oh my gosh, centiliters. And then milliliters is at the end. Now this is the order I'm talking about. You have to know the order of those prefixes. Now, it took me a second to put them out that way. If you can remember it using the phrase, let me do this again for you. King Henry died by drinking chocolate milk. So King Henry died by drinking chocolate milk. Okay? That's the kilo, hecto, deca. That's the base, which could be a gram, a liter, or a meter. That's deci, centi, and milli. That is the order, okay? Now, we said in that last table, we said if we had 1 kiloliter, that would be equal to 1,000 liters, right? So you could be asked a question that says something like, okay, if you have 1 kiloliter, how many liters is it, right? Convert the kiloliter to liters. Well, this particular case is easy, and we already know the answer, but technically if we didn't, right, what are we doing to go from kiloliters to liters, or from 1 to 1,000? Is we're multiplying by 1,000, right? Now we said when we multiply by 1,000, all it does is it takes a decimal and it moves it 3 times, and it moves it 3 times to the, moves it 3 times, moves the decimal 3 times to the right, okay? So if I took my 1 and I move the decimal 3 times to the right, boom, 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 there it is. There's my 1,000, okay? Now, I don't want to have to think about What are my base units? Am I multiplying, dividing by 1,000? How many times do I have to move the decimal? And I don't have to, because this little lineup here of our prefixes is going to help us. So if the question was, what is 1 kiloliter is how many liters, we are starting at kiloliters, and we're trying to get to the base, which is the liters, which is the base. And to go from along this lineup from kiloliters to that base, I have to move from kiloliters to hecto, to deca, and then to the base. That would be 1, 2, 3 moves of the decimal in this direction to the right. So if I'm starting at kiloliters and I want to move to the base, just along this lineup of letters, I have to move 3 times to the right. That's showing me move my decimal 3 times to the right. And it works with any amount. So if let's say I had 3.2 kiloliters, right? Some random number here. And I wanted to figure out how many liters that was. Well, if I'm going to go from kiloliters to liters, right? Kiloliters, to get to liters, I have to go 1, 2, 3 times to the right along that lineup. So move the decimal here. Let me add some zeros. 1, 2, 3 times to the right. So 3.2 kiloliters is 3,200 liters. Okay, so if we can remember this lineup, all we have to do is look at where we're starting, what are the starting units, and then what are we trying to get to? How many times do I have to move along this lineup? Will show me how many times I have to move the decimal. Okay, so let's try that out here. So 8 decameters to meters. Okay, let me write this out. King Henry died by drinking chocolate milk. So I'm starting at decameters, and I want to get to meters, which is the base. That's just one move to the right to go from decameters to meters, which is the base. So I have to take my 8 and move the decimal 1 time to the right, which means I'm looking at 80 meters. Okay? Same thing here. If I want to go from hectograms to grams, so King Henry died by drinking chocolate milk. I want to go from hectograms to grams, which is my base. So hectograms to grams, which is my base, I'd have to move 2 times to the right. So I have to move my decimal 2 times to the right. So I take my 35.7, let me add a 0 there. If I move the decimal 2 times to the right, I end up with 3,570 grams. Okay? 1.34 milliliters to liters. So again, King Henry died by drinking, oops, can't spell, by drinking chocolate milk. This time I want to go from milliliters to liters, which is, again, that's my base. So I have to go 1, 2, 3 times to the left to get there. So my 1.34, now my decimal has to go 3 times to the left. So 1, 2, 3 times to the left means I'm looking at 0.00134, and that is liters. Okay, now milliliters were already really small, so that's a really small amount of a liter, so it makes sense that decimal is really tiny. Okay, this is decimeters to kilometers or kilometers. Again, King Henry died by drinking chocolate milk. So decimeters is here, and I want to get to kilometers. So to go from decimeters to kilometers, I got to move 1, 2, 3, 4 times to the left. So I'm going to take my 24, decimals here now, and if I got to put some zeros there. If I got to move 4 times to the left, 1, 2, 3, 4, then I'm looking at 0.0024 kilometers or kilometers. Okay, milligrams to grams. Okay, King Henry died by drinking chocolate milk. So milligrams is here. I want to get to grams, which is the base. So if I'm starting here and I have to go 1, 2, 3 times to the left to get there, that means I got to take the decimal that's on the 40 and move it 1, 2, 3 times to the left. So I'm looking at 0.040 grams. And feel free at any point along here, right, to pause and like try out the next one, and then unpause it and see if you did it right. Okay. Let's see, we're going from liters to centiliters. Henry died by drinking chocolate milk. So I'm going from liters, which is my base, to centiliters. That's 1, 2 moves the decimal to the right. So I'm going to take my 3.2 and move the decimal 1, 2 times to the right. So we're looking at 320 centiliters. Okay, and then the last one again, I put there as you try. Feel free to pause and give it a shot, but we want to arrange these three amounts in ascending order. That means we want them to get larger, so this is smallest to largest. That's what it means to ascend. Now, in order for us to compare these amounts and see which one's the smallest, which one's the largest, they have to be in equal units. I can't just say, oh, that one's liters, it's the biggest, because the numbers are different, right? If it was 1 milliliter and 1 liter and 1 hectoliter, we would know. But since the amounts change, let's convert them all. It doesn't matter what you convert. Maybe we convert them all to liters. So let's deal with this guy first. King Henry died by drinking chocolate milk. If I want to go from milliliters to liters, which is my base, it's 1, 2, 3 moves to the left of the decimal. So 320 decimals here. If I go 1, 2, 3 to the left, then we're looking at 320 liters. 68 liters is less than that, but already in liters, so it doesn't have to be converted. But here, King Henry died by drinking chocolate milk. We want to go from hectoliters to our base of liters. So I have to go 1, 2 times to the right. So I'm going to take my 5 decimals here. If I have to move it 2 times to the right, then we are looking at 500 liters. Okay? So, which of the amounts is the smallest? This one is the smallest. And then 320 is in the middle. And then 500 liters would be the largest. So in ascending order, smallest to largest, 68 liters is the smallest, and then 320 milliliters is, what did I do there? I forgot my decimal. Guys, nobody's telling me anything. This is in class where you'd be yelling at me that I made a mistake. So 320, I moved the decimal and then I didn't write the decimal. It should be 0.320 of a liter, which means this is wrong. I'm so sorry. So the smallest amount is definitely 0.320 liters. So this is the smallest. And then 68 liters is in the middle. So this one's in the middle, in the medium amount. And then 500 liters is definitely the largest. So in ascending order, first should be 320 milliliters. Oh, look, they're already in ascending order. 68 milliliters. And then lastly, 5 hectoliters. Okay, so there it is. Making conversions in the metric system is as easy as moving a decimal. And if you can remember the order of the prefixes, base included, however you're moving to go from one of those prefixes to another is exactly how you're going to move the decimal, okay? Now take advantage of it being simple moving in the decimal here, because tomorrow we're going to look at making conversions in our standard system where it's not so easy, where you have to know things like, oh, there's 12 inches in a foot, or there's 5,280 feet in a mile. Now those conversions will be given. It's not like you have to memorize that stuff, but you have to be able to know how to use them. But that's for tomorrow. So we'll save that, put that on hold. As always, email me if you have any questions. Your math lab is going to continue for homework, and I would try to work on the assignments shortly after working on the notes, but you have your own pace. Remember, all the assignments are going to be due at the end of the unit as we prepare to take the quiz for the unit. And when we get to the quiz, it will be much like the midterm. It's going to be in Canvas, it'll be timed, but you get to use your notes and all that stuff. So I know this format isn't ideal, but I